Let us discuss DIT IFFT butterfly diagram. DIT stands for decimation in time and IFT stands for inverse fast Fourier transform. So we have to develop butterfly diagram for finding inverse of DFT coefficients. For that reason, I have written DFT equations and IDFT equation once again. These are the standard DFT and IDFT equations. Now we have already studied the matrix formulation of DFT and IDFT. So please remember that equation. We say that DFT capital X is W matrix multiplied by X matrix, and the IDFT X is complex conjugate of total matrix multiplied by capital X matrix multiplied by 1 by n. So when we are finding the IDFT, we are using this equation, and when we are finding DFT, we are using this equation. And essentially there are very much similarity between these two equations, and hence we say that IDFT can be computed by the same way as we compute DFT by making some changes. So if we make some changes, whatever the approach we use to find DFT, the same approach can be used to find IDFT also by making some changes. The changes are: change number 1, here you observe capital X, here you observe small x, here you observe small x, here you observe capital X. So we say that there is an interchanging of capital X and small x. See here also, small x, capital X, small x, small x, capital X. Second change is DFT requires W raised to nk terms, W raised to nk terms. However, IDFT requires W raised to minus nk term, and W raised to minus nk is actually complex conjugate of W raised to nk. So we say that IDFT requires complex conjugate terms, so that is, use complex conjugate terms while evaluating IDFT. And the third change is DFT requires, in fact IDFT requires an extra term called 1 by n. So the whole answer you have to divide by 1 by n. So if you make those changes, we can use the method of evaluating DFT coefficient for using IDFT coefficients by making these 3 changes. What it means by, I will discuss with this example. This diagram that we have drawn is the DFT butterfly diagram, and we have developed this in early lecture. This same diagram can be used to find IDFT if you make 3 changes. Change number 1 is replace this small x by capital X. So x2, small x2 has been replaced by capital X2 and so on. Small x, capital X has to be replaced by small x. That is the first change you have to observe. Then second change is use complex conjugate term, and you remember in 4-point DFT there is only one complex term, that is minus j, and you have to replace it by plus j. Second change. And what is the third change? You have to divide the answer by 1 by n. So after whatever you find after this butterfly stages, you have to divide the answer by 1 by n, that in this case 1 by 4. So this diagram can be used to obtain the inverse of any DFT. So let us solve an example. Say x of k is a sequence, or DFT coefficients are given as 10, -2 plus 2j, -2, -2, -2j. And here we have to find the IDFT. And we know the answer. The IDFT of this DFT is 1, 2, 3, 4, because DFT of 1, 2, 3, 4 is this. So let us solve this example. First of all, rearrange the DFT coefficient in the bit reverse order. First of all 0, then 2, that is 10, followed by -2, then minus plus 2j, followed by -2, -2j. So this is the bit reverse order that we have followed. Then what you have to do? Sum of these two numbers. 10 plus -2 is 8. 10 minus -2 will be 12. -2 plus 2j plus -2 -2j plus 2j -2j can cancel. What remains is -4. And -2 plus 2j minus becomes plus, and both terms become plus, and hence we get plus 4j. Then you have to multiply this -4 by 1, so we get a -4 here. 4j multiplied by j gives me 4j square, and that is -4. Here I should get, here I am getting 8. 8 minus 4 gives me 4. Here I am getting 12 minus 4, because here I am getting -4. 12 minus 4 gives me 8. 8 minus -4 multiplied by -1 is +4, so 8 plus 4, 12. And here I am getting 12 plus -4 into -1 plus 4. 12 plus 4 is 16. And this answer you have to divide it by 1 by 4. To get 4 divided by 4 is 1, 8 divided by 4 is 2, 12 divided by 4 is 3, 16 divided by 4 is 4. So this way you can obtain the IDFT of this number of this DFT using the same approach we applied by making these 3 changes.